Andrew, why don't you start us off? Because I don't see most of the expert folks here.
Yeah. Sure. Yeah. Let me. Can people see my screen?
Yep.
Okay. So I think the main thing that I want out of today's meeting is uh decide on a new export API for quantization based on the requirements from QAT, which is mainly pre-dispatch equals true. So I think the scope of this is has increased since like last time we talked about it, since if we want pre-dispatch equals true for QAT, then we also need to think about how the IRs are how the IRs compare to the ones in the non-quantization case. And yeah, it turns out that if we want this flag, then they will have to diverge from um, the non-quantization IRs. So let's first start by looking at this flow. I think there were some. So this is a flow that a few of us discussed, I think yesterday or 2 days ago.
Andrew, would it make
Yeah.
sense for us to establish what it is trying to solve? I think you highlighted a couple of problems in the beginning. I don't know if you covered those in the last composability
Oh,
meeting.
yeah, that's true. Yeah, thanks. So, okay, yeah, on a very high level, what we're doing is, yeah, provide better support for export plus training, and this is primarily in the context of QAT. So the problems here are that, first of all, uh, some autograd functionality like torch.nograd is not supported today. And this is because the certain ops that power these features are not traceable. So they'll simply be removed from the graph after export. So then, for example, if the user has no grad, then that will silently not do anything today. So that's a problem. One way to solve this is to use the pre-dispatch flag. That may be the only way to solve it, actually. Um, but then figuring out how to enable this flag for the quantization workflow is a challenge. So that's what I want to focus on today. The second problem is there are some ops like dropout and batch norm whose behavior is dependent on whether this model is in train or eval mode. And then today, because these are exported as an 18 graph, switching between train and eval mode won't change the behavior of these ops anymore because they're already like decomposed in the graph.
NYC Dark Ritual.
Could you give some details on why you run AutoGrad after export and why you cannot export the graph that already does the AutoGrad part?
Sorry, can you repeat that question?
So in a sense, like here you export the forward pass and then you run AutoGrad on that forward pass graph. But you could also imagine that you would export a forward plus backward graph.
I see.
And then use that because the only thing you need from AutoGrad is to get gradients, right? So you could also just say I have a graph that gives me the gradients. It doesn't matter how you got it.
Yeah, so I think you're referring to the joint like forward plus backward graph. So let's see. Yeah, so the reason why that's difficult for us to support today is because after exporting, we do this thing called prepared QAT, which inserts these fake quantized modules into the graph. So we do this only for the forward graph. And the reason is because we actually want an automatic backward graph that results from like these ops being inserted as well. So if we already have a joint forward and backward graph, and then we perform these this like custom graph transformation, then we would have to additionally provide the backward functionality as well.
Aren't these ops no ops for the backward?
No. So for QAT, we insert these things called fake quantize, which basically round the values to the quantized values, but then everything is still in FP32. So this is through like some multiply and some clamping, for example. Yeah, and these would require backward paths as well during training.
But the backwards for these is a no-op, right? Is an identity.
It's customizable. Like users can provide their own fake quantizer. Yeah, so for some mode, the default might be we use straight-through estimator, which is similar to identity, but it's not necessarily true.
Okay, Kimish?
So the one thing I wanted to understand is that for training on export, is the current the current thought process is that it's always done via either tracing the joint graph or tracing forward and backward graph, but never just relying on tracing forward and then AutoGrad to take care of it. Is that the thought process for export training on exported graph today?
I'll try to answer this one. So essentially, prior to QAT's use case, the general model was we had two modes. One was you don't do training, which is usually what we expect people to do. And in the rare case you needed training, which was basically just the ads APS stack, you export the joint directly. And there was no need to interact with the pre-dispatch graph. So QAT needs something new, and I don't know, like last week we did debate whether or not this would be possible or not. Sorry, whether or not we should do this or not, and I concluded that it probably was going to happen this way. I don't really see any alternative for them. Vasily?
Oh, I just want to add one more example, Alvin, to your question. It's a more difficult example than fake quantize. If you have a con followed by a batch norm and you do QAT, you need to swap in like a different version of this, which is more numerically stable, which is not numerically equivalent to the original version. So it's just an example of a much more complicated like transform, which you could do by matching forward and backward, but it'll be a lot of pain. Yeah, just wanted to...
Okay, I don't see any more hands. Andrew, I actually want to swap for a moment. So, Yanan, I'm going to put you on the spot because you've been, you prepared the PR that open sourced the torch.export API. Can you briefly walk us through, what so torch.export doesn't actually exist today, but it's going to soon in prep for the ExecuTorch public release. Can you walk us through what this API does today and what kinds of invariants we expect to get from it?
With regarding to training?
No. So basically Andrew is requesting, hey, I want this modification for the Torch export API so that it can work for training. But it'll be difficult for us to discuss this in this meeting. We don't even know what torch.export does today. So I want to spend a little bit of time establishing, this is what, ExecuTorch has been going down the path of, and here's what you get from torch.export.
Okay. So first of all, there seems to be confusion saying ExecuTorch is using this directly. ExecuTorch is using a different thing called EXIR, which has its own config, but it's built on top of Torch export. They have slightly different semantics. They can use different composition table, that sort of thing. Do you want me to talk about EXIR or Torch export?
Let me think. So my constraints are I only care about things that are in open source, although I guess EXIR is going to be open source soon. And
yes.
I care about, is it not the case that to the open source community at large, we are going to say, hey, there is an API that you can use to export models using PD2. That, we announced that we would let you do this last year at PyTorch Dev Day. I want to talk about that API.
Sure. So there's that's currently not the case today. There are two different APIs. The EXIR one is different, but I do have an
so we got
ongoing...
EXIR, we got torch.export,
yes.
And we also have torch dyno export. So you want to just walk us through them?
Sure. So torch export is the one open source API we're going to recommend. And for Dynamo export, we're not going to recommend it for several reasons. One is because it has too many flags, and Torch export kind of regulates which flag to be set to which value to meet the most user needs. And the second thing is Dynamo export doesn't expose the right kind of object model for users to sort of handle the graph more correctly, like the graph signature stuff we're moving. Dynamo export will kind of change the graph signature to mismatch with the original user code, but for Torch export, we're going to try to preserve that signature. So we do not recommend Dynamo export. We do have an internal experiments, but we're trying to migrate them away. For EXR export, right now it basically does Torch export, multiple Torch exports, plus some executorch only features, things like scalar only getter methods, where it'll say, hey, capture this module for me. I want these method 1, method 2, method 3, and these additional getter methods. So what you do internally is it calls Torch export with a special decomposition table, and it runs the getter methods, record its value, and add them as special kind of dictionary of string value sets to the program, so the user can get these configs during runtime. So there's an ongoing discussion of saying changing EXIR's kind of API to one that user have to call Torch export explicitly, and then use EXR to aggregate the programs, the exported programs into one EXR program. Then if we do that, then Torch.export will be the only recommended API user need to call to export a PyTorch graph. Now come to what kind of a things Torch.export do and what invariants we provide. Basically, Torch.export does two things. One is it traces through Dynamo, which will kind of unravel all the Python complexities in the user's Wild West PyTorch program. After that, we will get a rather kind of normalized Python program consisting of more straightforward FX graph containing every type of node FX graph can contain. And then we run through AOT export. And this step, three things happen. One is the parameter lifting, functionalization, and also kind of autentification. Functionalization means that we'll try to remove all the in-place modifications and try to make sure the graph doesn't kind of have states that's hidden from user view. Parameter lifting means param and buffers are no longer present in the graph as get adders. Instead, they're all kind of hoisted outside of the graph, and users are supposed to provide them as inputs. This also helps with functionalization, also helps with, say, when we serialize, we can separate the data from the program. Third thing is authentication. This is translating all the call modules or composite itonops into more decomposed ones. As for the variants we provide are pretty much guaranteed by the steps we perform here. We're gonna get a pseudo functional graph. I say pseudo because there are still things that are not truly functional, but we pretend they are. Things like assert or constraint range. Users are supposed to get a mostly straight line graph, meaning that there are not going to be complex call modules in there, but there will only be calling A10 ops one by one, modulo the existence of control flows. What else? Yeah, I think that's the key variants we're following here.
Okay, thanks a lot for the description. Andrew, do you know where to go with this?
Sure. I think I can talk about what we previously discussed before QAT as the workflow for quantization in general. So
Actually, let me okay, let me direct a little. Andrew, can you propose a change to Torch.export? Your best proposal, and then we will talk about it. So that it satisfies the requirements you told us about at the beginning of this meeting.
Yeah, so the main requirement.
I see a lot of options. Which option do you actually want to present to us?
So I'm hoping to get some feedback on the various options. I feel so previously we had discussed about exposing the pre-dispatch flag in Torch export. But then, so I'm under the impression that torch.export is trying to return a functionalized graph, but then this would be difficult to produce if pre-dispatch is equal to true. So that's why like we might not want to add this flag to torch.export. Also, based on what Yana just said, like we try to limit the number of flags we export compared to like dynamo.export. So yeah, that's why I feel like there may be some pushback against this. Is that, do people
So
that
everything you said is true. So do you still want to propose this?
yeah, I feel it would be difficult to go forward with this given these constraints. So maybe I should talk about the other two.
Unless there is a strong objection to it, get absolutely no way we can do it. I would like at least keep the option open.
I have strong objection
I
to
have
option
strong,
1.
I am strong opposing against option 1.
Okay.
Vasily?
Oh, I guess I would, if it's something not option 1, I think it would be really nice to get support from the compiler team on like the export pieces instead of the quantization team like building their own export again. So I just wanted to say that.
Rodrigo?
My study is that if we export pre-dispatch, that would allow us to do some operations easily. Like for example, applying distributed on top of it, because if that changes, that would allow us to carry the autograd semantics automatically in that backwards pass. It seems like this mechanism of pre-dispatch would be useful for other use cases, like the full graph distributed compilation.
So I'll restate what I think Rodrigo said, which I agree with, which is that I do think the pre-dispatch export is likely to get more users beyond quantization. Like it is a coherent concept, and I suspect that people are likely to want it for other things.
Who are the potential users?
So Rodrigo gave an example of whole graph capture. I guess Rodrigo, you're probably coming at it from a distributed perspective. Is that right?
Yes. I'm thinking that this would be really useful for exactly what distributor would need, which is a graph, like before dispatch that we can manipulate and then lower to dispatch. Because we had this problem that we needed a pre-dispatch graph, but couldn't always capture that.
And also to add one more before I call on Vaz, anyone who is doing a FX like graph pass prior to going into PyTorch 2, these are all pre-dispatch transforms, and so if you want them to use the PyTorch 2 export mechanism instead, they will probably ask for this sort of thing. Although they'll probably also ask for things like, oh, can we have module swapping, which is its own thing. QAT, I don't think, just to be clear, QAT, you're not requesting preservation of modules. Is that right?
I don't think so.
Yeah, okay. So you don't need that. But module swappy type things also much easier to do pre-dispatch. Vaz.
Yeah. Dynamo export grows in breadth all the time and complexity. And now we have Torch export. We're probably gonna have more exports. Should we take a step back and maybe design one export that isn't spread across a bunch of different layers and isn't piecemeal serving what people need? But when we first wrote export, we had no idea what all the use cases were, but now we have a really pretty good idea, including users that we haven't really brought up in composability sync but need it just as much, like higher order ops, cond I believe, is going to always be running some safety checks under inductor, or at least under PT2, and going all the way through to inductor with them. So like, should we take a step back, or should we just keep like doing stuff like this and then at some future point redesign, or maybe never redesign?
I think what's really pulling us apart is the different user requirements. So if we say come up with a new thing, which we're trying to do exactly right now, we're being kind of pulled into different directions. If some users want pre-dispatch and some do not, which I think kind of still most users want a more decomposed graph. Therefore, pre-dispatch is not going to work for them. Then it's two set of very different users.
There's something wrong with the TV.
Subset. I'm sorry. Set of very, very different set of requirements. Where was I? So we need to address that first, and then we can modify the torch export to kind of work with that.
NYC Dark Ritual.
Are there actually that many different use cases? Like, everything here just seems like different variants of like decompositions, or whether it runs through dispatch or not, which like isn't too difficult conceptually, but maybe I'm missing some of the use, like the other use cases.
To restate what you said in a different way, if you think about like the end-to-end export process as a pipeline, essentially what torch.export is a pipeline that takes you from the beginning all the way to the end after everything is done. And people are asking for, more stop points in the middle so that they can get out a graph.
Yeah, so yeah, I get that. So like one answer to that is you just make each point explicit, right? And that like requires probably a couple lines of code instead of one torch.export line, but it all seems conceptually like coherent.
Elias?
I guess have we discussed maybe this is similar to option 3, but it's not clear to me why you can't do the like quantization modifications like post dispatch, post AOT autograd, and like record which buffers you're making this is maybe option 3, yeah, like record which buffers you're making modifications to, and then like work back the correspondence when you like apply the modifications on say like the modules in pre-dispatch, then re-export it again. And like, I don't know, it'd be nice to define a way where the analysis is not like, yeah, we're not introducing a new IR, and at the same time, like the modifications we're doing to the exported train graph get applied to exported inference graph. And I don't think it shouldn't be like, it seems conceptually like it shouldn't be impossible to do that.
I think like to the point of having a pipeline, I think that's very compelling. One of the issues that export keeps running into is that like fundamentally it's implemented as a backend into like the PT2 stack, and the way, and so you kind of have to do it in one shot. There's not like a great way to sort of like iteratively add stuff as you're going along, or to like lay out a pipeline of steps and then do it with how it's architected today. Because if you know how we do our backends, everything has to be defined in one backend. You can't say like run this and then run that. You have to have a function that then does that within itself. And so like export just keeps growing broader because you need all your options up front. So it feels like if we were to do pipelining kind of design for export, where you can lay out your stages in like a builder and then run those, it seems like you would have to sort of do that change for all of PT2. I can't imagine a way to do that for just export.
Yeah, I'm going about that point too. So why couldn't we build a pipeline? If say we expose the pre-dispatch as the kind of default behavior, then we have say passes, which may not be supported today. Passes, let's say, oh, run AOT dispatch for me, and then run this decomposition for me, and the user can choose to stop at whichever point they want. And that's kind of a unified pipeline. And if we can get our kind of infrastructure in place, meaning decomposition are kind of expressible in a compiler path, then this will work beautifully.
Sorry, just to ask for a quick clarification. Do you mean like you have a single export function and you pass in the pipeline stage processors you want, or more that you have a bunch of individual functions that you can call one by one that get you
a bunch of individual functions you can call one by one after the fact of export, meaning export stops at the very early stage, and then you can go further and stop wherever you want.
Kimish?
So I was just going to respond to Elias' comment around like the difficulty of applying the transformation on forward and backward. Is generally generally harder to figure out like where what is the exact backward node corresponding to say a matmul node, and then if you have fake quantized nodes which are like somebody can write their own fake quantized modules. Then you are responsible for figuring out what the backwards of that would trace to, and then figure out how to insert those in appropriate places, right? So I don't think it's quite trivial to do it. So I just want to respond to that.
Tugs? Okay, Elias, go. Quick response.
Yeah, it just would be nice to, I guess, like see that. I don't know if that's see that like detailed more, like the difficulties more explicit. But I mean, like I assume that we already have a lot of restrictions on like what we're exporting that would make it easier than maybe it was in the past. But I mean, yeah, I take it. I acknowledge that it may be difficult, but it may not be like unsolvable, and it may be better than introducing like a new IR that we have to like maintain.
Taksu?
Yeah, so I was just gonna say, so today export returns export program, and we are still going through all this pipeline, right? So what if we just store like each intermediate values in the export program, so like whoever wants to use it can just get anything they want from it, and we commit to like support re-exporting, so that in the end you can get like 8-10 level graph.
NYC Dark Ritual?
Yeah, I have a follow-up. So I think there seems to be an agreement that in principle, this is a pipeline of like, we have these 3-4+ independent steps that apply after each other, and that we would like to be able to choose and pick and choose basically what is applied or not. In my head, that matches very well our source compile stack. But today, our source compile stack can absolutely not be used in a separate way. So I would be curious to hear from Voz or Brian, what is their take on like, do you think it's technically possible for us to actually separate these pieces in such a way that we can choose which one run? Or are we going to go back in a similar situation of our compile stack where they are just too linked between each other that it is not feasible to separate them? And we need big blocks for each of the things we need.
I've been talking a lot if Brian wants to answer, but I have thoughts on this.
I can go quick. I think separating them is very feasible. Like in theory, you could totally imagine you have these stops in the train, like torch IR, pre-dispatch IR, functionalize post-dispatch ATEN IR, and everything. And if you look at the inductor compiler steps, it does that. And then your question is like, should that be a user explicit UX, or should that all be done behind the scenes? And maybe one part to that answer is that, at least in the inductor case, and inductor people can speak to this better than me, I imagine that those different steps are pretty linked, where inductor does stuff, at different stages, and it sort of needs to know about information being transferred across those things. And maybe that's true for the specific case of compiling with inductor. That doesn't mean it's always true for something like export. So I don't know. I think it's possible. I don't think it's true for every conceivable backend that you might want to compile stuff with, but
Yeah, I agree with that. I had a PR that they just abandoned because it was like not adding value, but adding a lot of complexity. Where compile fx inner, which is like how AOT autograd and inductor combined together, was I sort of rewrote it to see if we could do it in steps like this. And the biggest issue is like, did I just make a contract for something that was like incidental, that wasn't planned at the boundary of those two things? And what value is this adding? And it didn't seem to add any value. And so if we do this for export, it feels like we should do this for the rest of the stack too. And it seems like it still would add a lot of complexity to the inductor stack without value, because inductor works well now, and reshuffling those pieces I think is kind of going to be a pain.
Okay, so in your head, the cross-cutting features like shape env or guards or things like that will not be a blocker for us to separate these things completely.
No, and the way it used to work is you used to call inductor firmly after dynamo, and now dynamo subsumes calling it. And so but like now that we have a tracing context, I feel like as long as you keep that alive across all the stages, you should be able to accumulate cross-stage information like guards and shape.
Okay, I'm going to intervene, and in particular, is anyone here signing up to pipeline PD2 stack? No? Oh, that's what I thought. Okay, so I'm going to propose a solution that doesn't involve pipelining to move the conversation along. Andrew, can I grab the screen?
Oh, yeah.
Thank you.
If the only good reason is no one wants to do it, then maybe we can just find someone to do it instead of doing something less good.
Does anyone want to advocate for doing?
I'm okay with advocating for it.
Okay, then I'll give two proposals. One which is a pipelining proposal and one that's not. Okay, so all right, let's start with a pipeline proposal. So the essential idea, sorry if this is small, let me make it bigger. Give me a sec. So I'm gonna simplify things because we were talking about like compile inner FX and things like that, and that's not what QAT needs, right? So QAT needs one stop, and it's the stop it needs is start off with original user program. They need to get off at the pre-dispatch IR stop, and then I'm going to call this exported program. This is the traditional stop that export is able to get you. Okay, so what this means is we need two functions. So we need a function that does this. We need a function that does this. Okay, so I want to do the thing that everyone hated, and then we'll talk about it. So for function A, I propose this is torch.export pre-dispatch equals true. And for B, I propose this is torch.export. Okay, discuss.
So the A you can return like non-functional graph, right? So
So basically the flag controls the invariance on the returned thing, and like obviously there are variations of this, right? So you could do pre-dispatch export with perhaps a different return type, or lots of other variations. But because we're taking on the pipeline idea, we have to define a new pre-dispatch IR. I know this is what Elias really didn't want to do, but we have to define this IR, and you have a function that returns that IR. NYC.
I just have a slight modification suggestion, which is that we should model the thing as a pipeline if that's what we're going for. So instead of like pre-dispatch equals true, you say stage equals pipeline or like something. And the default thing can be, you know, defaulted, but that just prevents us from like exponential arguments.
So I don't know what to call these stages. So
well, the first one is called pre-dispatch, right?
Okay.
And the last one is like, I don't know, A10 IR decomposed or something. I don't know.
Let's call it AOT dispatch. Yunan.
Another minor suggestion. If we do the stage thing equal to pre-dispatch or dispatch, it just seems like a syntactic trigger for calling a path manager after export. If we say just have one export API that leads to stage A, and then ask user to run passes to lead to other stages, then that seems to be a cleaner abstraction. And we still have only one API. User won't get confused on which one to use.
Yeah, okay. So Andrew, I need to bat this back to you. So in all of the proposed source code docs, you prefer to call the export function separately. So Yanan is proposing inversion of control, where instead you pass prepare PT2E as like a callback inside the export, which calls you. Tell me if this is okay or why this doesn't match your requirements. I actually don't know. I don't think your stated requirements say one way or another.
Yeah, so we actually discussed this last half as one of the options, but the problem with that is it's very different from the existing UX in prior modes of quantization like FX graphical quantization, and also PTQ, which is the other side of the quantization that doesn't require any of this. That one doesn't require so that one can be completely separate, and we want to make sure that the UX for QAT and PTQ still match. But then if we do that as part of the like a hook in torch.export, then they're going to diverge significantly. So from the UX perspective, it's not great.
Did NYC have a follow-up? Vasily, go. Yeah, Vasily?
Oh, sure. I just wanted to add one more piece of color. So a QAT run might take like a few weeks. So what a customer is doing is like they do the first export thing, they could save it, they load it in a different environment, they train it for days or weeks, and then finally at the very end, they do the final like thing. So I just wanted to clarify. That's what the users.
Timish?
So I didn't quite follow what proposal here was. Is it just like passing a callbacks that the export pipeline will call at different stages or at a particular stage? Like I didn't follow what the
So yeah, concretely, there is some function that takes in pre-dispatch IR and produces pre-dispatch IR, and that's a pass. That's a pre-dispatch IR pass, and you put it into a pass manager, which you call when you call export. Supriya?
Yeah, I also wanted to add that QAT as a transformation is not numerics preserving. So I don't know if that would be unexpected for the user if they run a pass and the numerics of the model changes. And
Yeah, I agree. It's just, it would be really nice if it fit into like the path model, but it just doesn't, in my opinion, which really complicates things.
Okay, Yanan, you have any other comments? Otherwise, I'm going to quash pass manager. All right. sounds good.
I wasn't exactly proposing a path manager. I'm just saying
okay,
like they can be like separate steps. It's not exactly version control where you pass in a callback. It's like you call export and then call something else to kind of turn into the next stage.
Yeah.
Okay.
So it's not a one-shot process. It's like a multi-step process.
So then, we currently are shoveling this into torch.export. Do you have a different phrasing of the API that you want to propose?
The phrasing is export is only called once, and it's only used to generate the first stage, and then you use something else to generate the later stages. And there are transformations.
I think that doesn't work if you need things that are ostensibly before it or in the middle of it, and then you kind of have the same problem again. It should be
Before
like
what?
like for example pre-dispatch. Like some would say that that's actually before what others would call export. Like it's subjective as to what the first step is. It seems like it should be the same API for every stage.
Jiangshu?
What if
yeah.
we just sorry, Jingshu.
Yeah, so my preference is like variation A plus like torch.export doing everything, including AOT dispatch.
Taksu?
What if we separate the pre-dispatch and AOT dispatch into two different functions, and torch export just calls both of them underneath? Like capture to pre-dispatch and then capture to AOT dispatch, then torch export will just combine these two by default.
I think this is Yanan's proposal, but with different names. So did you have a response to Vaz's point that like what is first is not well defined?
I do feel right now it's more or less well defined. Pre-dispatch is the very first thing. Like what's before that?
Well, technically, you can also ask for Dynamo IR, which is not pre-dispatch. I don't think we really want people to be able to do it, but like it's certainly how like Inductor is doing passes right now. Is that true? No, actually no. I think this is like the only thing that really does this is like FSDP optimizer, DDP optimizer. I mean, not FSDP optimizer. Taksu, did you have another comment?
No, I mean what I was just saying is like export is like we still maintain like the invariant that export returns functional latent IR, and all this are capture to pre-dispatch. Like we don't give any guarantees. It's just we just return graph module for each of them.
Well,
I just wanted to kind of restate Yanan's proposal the way I heard it in case it's helpful. Like I think what he's saying is that maybe we would consider export as always, like think about dividing export in two halves and the user only, so then export becomes one thing that always does pre-dispatch export, and the thing you get from export is always pre-dispatch export. Then you'd have to define like a second function that would be like the rest of export, and we'd have to have a name for it, and users have to call this thing. Some users would have to call this thing. Is that what you're kind of saying, Alan?
Yes, except it may be many halves, not only two.
So it's like maybe a complete unbundling of things and like more explicit objects in between.
Yeah, and we need to be opinionated on what these stages are.
I guess my rebuttal to that is that we thought we knew kind of what export needed, and then pre-dispatch came out and other things came out. Just because it's first today doesn't mean it'll be first in the future. And the whole point here is to like make it easy to mix and match parts and order and things like that. And so if we just pick one that is first today and canonicalize that as the export, that's just going to grow broader again, and we're going to have to redo this exercise. So it seems like we should maybe think about like not over indexing or opinionating on that first step. And like if you happen to have to call torch export a few times where that one is required as a first step for now, that seems preferential to canonicalizing a true first step.
And you mean making kind of stage a argument will make that more flexible? we can just change the value whenever we want in the future if we find an even earlier stage?
Yeah, I think it's a detail if it's a builder or is it arguments or like what the actual code structure looks like. But as long as it's not like indexing on that first thing being first forever.
Changshu?
Yeah, I also think I do want to preserve some like room for like changing the behavior for the future, and like preserve like one default like standard way to export stuff instead of like giving user like too much power, because as people mentioned, like we don't know actually what's gonna show up in the future. And I kind of think of like our current user group being majorly Edge, maybe Torch XLA and some as model, and none of them need this kind of like pre-dispatch stage IR, but only for quantization for now we need this thing. So I don't want to make it too complicated and make sure our API can compose with each other and have user use the lower level API to do that.
Okay, we have 10 minutes left. Andrew, I want to swing this back to you. Have we answered the questions you wanted answered for the QAT question?
I would say not really.
Okay, so let's
go back down. Oh, sure, yeah, Eric, we can share my screen as.
Okay, let me let you share.
Okay, so it sounds like there are many different kinds of export today, and people haven't really decided. For example, if we do end up doing the pipeline thing, that's gonna take a while. So in the meantime, I guess we still need to figure out what quantization should do. Today we're using just torch dynamo.export. But then we're also thinking about what should we tell our users when we release PT2 QAT as a prototype. Like, should we just tell them that this is going to be the export API for quantization for now, or like that's subject to change once we have the pipeline thing? Or I think that is still something we need to discuss.
Okay, let me try to answer these based on my understanding. So as a unblocking measure, so not as a public API thing, I think using Torch Dynamo export directly is compatible with the stages proposal. In particular, you are essentially hand implementing a function in not the right API shape, but it does the same thing. That would be as if you had passed stages pre-dispatch. So like behaviorally, this is right, even though the API is not correct. Kamish.
So in that, are you saying that doing a dynamo.export with pre-dispatch is equal to true? That's the acceptable API because it aligns with the future plans.
I'm stating, sorry, I'm arguing that it is aligned with the stages API. Feel free to disagree with me, anyone in the room, but it seems compatible.
But as far so makes sense. But as far as exactly like whether we use a pre-dispatch is equal to true or not, we are still talking about that being something that we would use. Is that right?
Yeah,
Andrew, or
because
saying that
even in the universe where Torch export supports it directly, you essentially say Torch export stage equals pre-dispatch, and then you get a function that does the same thing as the thing you would have done with Torch Dynamo. Maybe you should have a wrapper function around Torch Dynamo export, so you have less knobs that are available to the user.
So I do want to say that this in terms of engagement with vendors like Qualcomm and Apple that we are doing, we need to also provide API for quantization to them, and current proposal, I think the way it is aligning is that if they are working on top of executorge, them doing EXR capture is not going to give them get them to this stage. And I think Yanan mentioned earlier that we actually are still I'm not aware of it, but we are debating around whether we're gonna do that at a more staged API where you directly call torch.export and the subsequent edge specific things happens later. It probably aligns better. So that these both of these questions are relevant. One is like on the quantization side, like we need to say, or even the export side, if you want to do quantization, this is the export part you need to take, and subsequently you go continue your journey towards edge specific export. And in order for us to do that on the executor side, we have to make the export APIs clearer. And this would actually is more eminent, right? And we need to do it soon enough, like so at least I think going via dynamo export is fine, but I do want to highlight that this would have to be aligned for us to, otherwise 2 months down the line we'll come back and say, okay, that's we are going to do something else again.
Vasily?
Yeah, I just want to share some product context. So we're figuring out how to do GPU quantization for servers this year, and we're punting the alignment of server quantization of edge quantization until next year. So I would expect actually things might need to change for edge quantization next year, depending on if you want to like keep it forked or align the two. And if you do want to align the two, I would expect something like option 1 to be like what server would ask for. So I guess it's not the best situation for edge, but I guess I just wanted to share what's going on at the server side in case that impacts any plans for edge.
But I think that the option one and option 2 difference is just what API you're using, but otherwise, like we still gonna continue to have to use pre-dispatch is equal to true in both options.
Like continue to use what in both options?
Pre-dispatch is equal to true for both options. So,
right, that's correct.
So I think that's okay as far as the, so if as long as we get the IR that is not drastically changing between now and say a year later, I think that might be okay. It's API call differences, but that's okay. Because what's going to happen is that the partners and whoever is writing this quantizer to actually tell quantization workflows like, hey, this is our quantize, this exactly piece I want to quantize. In order for them to do that, they have to parse the graph and have to, so they have to work with the IR, and that IR drastically changes, which means a lot of work for them. Right now, that's what is going to happen for us because we have some quantizers on example.
Yes, this is released as.
But I do want to push on the IR question for a moment. So based on what I've seen Brian and Andrew working on, the IR you will see for pre-dispatch IR is that it will have most composite implicit autograd decompositions applied. So you actually do expect to see mostly the same A10 operations that you would have seen if you had gone all the way. It'll be a little less decomposed because any decompositions that are not differentiable we're not allowed to do. And you'll also have mutating ops, and you'll have like autograd the ops that like I assume people have to know how to like sort of ignore without getting rid of them. So at a rough approximation, that's what the IR spec is going to look like. Obviously, and probably quantization team is going to have to drive this. We'll need a more like detailed description about what this IR looks like, but hopefully it still resembles post-dispatch. Andrew, back at you. So is this unblocking for you?
Yeah, I think so. So I think the only conclusion so far that it sounds like even if we want to use torch.export eventually, and I think that's the case, right now the immediate solution of adding the pre-dispatch flag as is to torch export, that's not something we should consider. But in the future, once we have the stages thing, then we would want to switch back to torch export.
So if you want to do the public API change earlier rather than later, here's the like MVP. You add a stages argument to export. It takes a list ? And one of the valid elements is pre-dispatch. And when you call torch.export with pre-dispatch, you get an exported module that had stopped before actually running decomps or AOT export. This is a problem because exported module actually is very specialized for the AOT export case. So this will need some discussion as well. Tugsu.
Yeah, so instead of doing that, why don't we just have like different export APIs, and then the parent export just calls all of them? Because the problem with export getting like list of stages argument is that it needs to return exporter program, but it's kind of hard to define what exporter program is for like each stage. Like currently exporter program has like graph signature for prime buffer and stuff, right? So like if you do pre-dispatch, then it's like it's also hard to tell like what those gonna be. So instead of what if you just like have different APIs and the export just calls them underneath.
So as a
and if you want
matter, the signatures is fine. You have that immediately after Dynamo, and parameters and buffers can also be fine because you can get adderify them without running all of the autograd. The stuff that's hard is like functionalization and calling convention changes. Jiangshu?
Yeah, I just want to say I want to second Tuxu's proposal, simply because to me, like each API should does one thing, instead of two. And if we are like putting stages into as argument, seems like it's very hard to define what we return eventually to user. And if we just say, okay, we're exporting a different IR, right? Why we couldn't have a different name, right? So that's kind of what I'm thinking.
Oh, just going to say that adding stages is yet another problem, because what's the default behavior for a user doesn't specify any stage? We still need to be opinionated on what to do there, and that'll effectively become our first stage, per se. Just pointing out.
Brian?
Just as like a minor counterpoint, I think at least when I looked at the exported program type as it exists today, I don't think anything in it codifies in the type exactly what the IR is. And so in theory, I think like whether or not you're at the pre-dispatch level or AOT dispatch level, that can all be represented at the very least using that existing type. So like question if we want to reuse it or if we want a more structured type that like better represents exactly what the IR is. But I think both of those are possible.
Jiangshu?
Yeah, I want to point out that it's not codified what exported program today, because we haven't finished the work, but we do have some invariants we want to enforce on export program. Like one thing is like definitely functionalization, which is helpful to all the users we are currently supporting. Yeah.
Voss?
This is a deja vu of Sherlock IR discussion from months ago, except at a different layer, where like, stronger IR enables more and is better contract versus flexibility. And I think we opted for flexibility last time. So maybe we should revisit those and look at why we made that choice.
One parting thought? Okay. So thanks everyone. We're over. I'm going to propose that we take up a slot in the Friday export meeting to discuss this some more. I think like going over export program maybe in more detail, that could be profitable. Hopefully quantization is unblocked from here. I think basically it's like keep doing what you're doing, but you should probably not tell people to use Dino export directly. Like at the very least, make a wrapper function around it. And yeah, hopefully we can get you more on the public API question this week. All right, thank you everyone.
Thanks.